Okay, so let's start with the first, and that's the tangent vector. Okay, and it's t, and it's a unit vector. So all of these things are unit vectors. Okay, and I'm not going to draw the hats above, just because it gets a bit tedious. Okay, so you should remember that these are 3 unit vectors. So tangent vector, so tangent, we have the t. Okay, and you've seen this already. At this point, maybe we can start again actually. Okay, so let's have an origin. We have r at time t, or parameter t, and then we said let t move on a little bit so that we get r t plus some infinitesimal time dt. Okay, and this is our curve. Oops. Okay, so there's 2 points on our curve, and we said that the difference between this and this, so this minus this, is dr, this vector dr, okay? So we saw that before. And then we said that ds, the arc length, the element of length, was the modulus, so the magnitude of this vector dr. Okay. So this tangent vector t, if you make this, the dt really small, so as dt goes to 0, these 2 points become closer and closer and closer together, and this dr points in the direction of the tangent to the curve. Okay, so this tangent vector is nothing other than the dr. Okay, but it's a unit vector, so we make it a unit vector. Okay, so remember any vector A, okay, can be written in terms of its magnitude and its direction. Okay, so this is the unit vector A. Unit vector A equals the vector A divided by A, and A here is the magnitude of A. Okay. So what we've done is make dr, we've divided by the magnitude, so we make this a unit vector on the right hand side. Okay, we know what mod dr is, it's ds. Okay, so this is dr by ds. Okay. So remember, when we change the parameter s, it moves us along the curve. Okay, we walk along the curve as we change s. So this derivative, so changing with respect to s, means how you change r as you move along the curve. Okay, and remember we know that ds can be written as, let's say, dr by dt. So if there's some parameter t, then we can write it in terms of that. Okay, so in this case, if we use this, we have dr vector by d, and s, ds is this thing, dt. Okay, so we'll get a dr by dt. Okay, with a dr by dt on the bottom also. Okay, so let's write this as r prime t dt. Okay, so then we have a 1 over r prime t. Okay, but dr by dt is just r prime, so this is just r prime of t vector divided by its magnitude. All right, so this is just a unit vector pointing in the direction of dr by dt. Okay, and if you remember back to your mechanics, let me get rid of this. If you think of dr by dt as the velocity, this is just the velocity, instantaneous velocity, so the velocity at any time t, divided by its magnitude. Okay, so the tangent to the curve will be given by, will be in the direction of the velocity at any time. Okay, so this is the velocity corresponding to motion at this point. As we move around the curve, the tangent changes direction. Okay. Okay, so if we were to draw a tangent vector at this point, it will point in this direction, at this point in this direction, this direction, this direction, etc. Okay. Okay, so let's look at an example. Let me rub this off. Okay, so let's look at a straight line. Okay, and remember our coordinate at any point on the straight line was this thing, r of t equals some constant vector a plus u t. Okay, so what is our tangent vector here? Okay, so remember our straight line, we had an origin O, we moved some vector a, there was some vector u, and the straight line was mapped out by scaling this u by t. Okay, so we change t, and this endpoint moves along this line. Okay, so t equals 0 is this point, t greater than 0 up here, and t less than 0 are these points on the line. So this is our straight line. Okay, so what's our tangent vector here? T equals, so let's just do this. So this t is dr by ds. Okay. Tangent vector t is dr by ds, and we know what ds is. Okay, it's r prime magnitude dt. Okay, so we've got the working formula. So we need just to find the derivative, r prime, and then find its magnitude. Okay, so the derivative of r prime of t is what? So if we differentiate a with respect to t, what do we get? Okay, 0, because this vector a doesn't change with t. This is always constant. Okay, this vector a is constant. So dA by dt is 0. And what is du by dt? Well, it's just u. Okay, so a and u are just constant vectors. Okay, so that means the magnitude r prime of t, which is on the bottom line, is equal to the magnitude of u, which we just call u. Okay, so the tangent vector t for the straight line is just r prime of t, which is equal to u. So it's dr by ds, which equals dr by, and s is the magnitude of r prime of t dt. Okay, so that's just r prime of t divided by its magnitude. Okay, so I'm just writing out what's above again. And we've just found what these two quantities are. It's u divided by the magnitude of u. Okay, which is a unit vector in direction of u. Okay, is that what we expect? Yes, it is. The tangent to this line lies along the line. Okay, it's a straight line. Okay, so this is a rather simple and obvious case. Okay, so remember this t is always a unit vector. Okay, so if you're asked to calculate the tangent and your answer isn't a unit vector, then you need to think again. Okay, and just consider what you've done. All right, so maybe we can look at another example. Okay, let's look at a second example. Let's think about the circle. Okay, so remember we have our circle of radius a. Okay, circle of radius a. x and y, and this r of t is the point on the circle, okay, and this t is the angle between the x and this coordinate r, okay? Okay, so in this case, r of t, okay, we're familiar with this by now, hopefully. It's a cosine t, a sine t, okay, which means that r prime of t, so dr by dt, equals minus a sine t, a cosine t. Okay, which means that the tangent vector at any time, or any parameter t, okay, so this depends on t basically, that's what we're saying, equals, to remember it's dr by ds, that's the definition. Okay, and we know that if you just write what ds is, then this will give us r prime of t divided by its magnitude. Okay, so this is just r prime of t. Okay, so it's the vector that goes from minus a sine t. So it's a sine t is the x component, and the y component is a cosine t. Okay, and we divide by the magnitude. So there's a magnitude here, and that magnitude is just a squared sine squared t plus a squared cosine squared t, all square rooted. Okay, so that's just dividing by a. Okay, so this tangent vector t is equal to a vector with minus sine t as the x component and cosine t as the y component. Okay, and you can check this as a unit vector. Mod t equals sine squared t plus cosine squared t, which equals 1. Okay, so it is a unit vector. Alright, so in which direction does that point? Well, if this is r, that's equal to a cosine t, a sine t. Then minus sine t, cosine t points in a direction that's perpendicular to it, this way. Okay, so this is the tangent vector t. Okay, so it points in the direction of the velocity, as we said. Okay, so this r prime t is just the velocity v. So if you're going round a circle, then your instantaneous velocity points in a tangent to the circle. Okay, so at this point, the tangent vector is in this direction. At this point, the tangent vector is in this direction. At this point, the tangent vector is in this direction. Okay, so you can see this tangent vector changes as you change t, because changing t changes the position on the curve at which you are. Okay, so hopefully that's clear. Okay, so the tangent vector is just this little dr vector, but a unit version of it. Okay, so it's dr by ds. So t equals dr by ds. So burn that into your mind. Okay, so next up we'll look at the normal vector.